Welcome to ISAP, the International Forum for Sustainable Asia and the Pacific 2021, organized by IGS, the Institute for Global Environmental Strategies. We are very pleased to start the thematic session number 12, titled Cutting Methane Gas from the Waste Sector, Crucial for Zero Carbon Societies in Asia and the Pacific. I'm Kumara, Director of IGS CCET. I will moderate the session today. There is no doubt the importance of having better waste management and resource management in achieving zero carbon societies in Asia and the Pacific. The sixth assessment report of IPCC, Global Methane Assessment Report, and the recent Global Methane Pledge signed by more than 100 countries at the COP26 also acknowledge the importance of addressing methane from the waste sector. However, if we look at methane only based on the IPCC numbers, the sector was a relatively small contributor to global greenhouse gas emissions. This makes not a priority for investment when it's come to mitigation actions at both national and global levels. This session therefore aims to find a major picture of the waste sector, that the emissions from the waste and resource management sector itself are far outweighed by its potential for enabling across multiple other sectors of the economy, both from the waste recycling, recovery, and the prevention. To discuss these issues and the challenges and the opportunities, today we have three distinguished speakers with us. Thank you all for giving us your time and joining with us. The session will be 60 minutes long, and I hope you will enjoy and actively participate throughout the session. Without not taking much time, let me first introduce our first speaker, Mr. Nathan Rockford-Parnell. He is a Science Affairs Coordinator, Climate and Clean Air Coalition, CCAC, UN Environment Program. He will give us a broader understanding how waste sector is framing within the methane and the greenhouse gas reduction. So, Mr. Nathan, the floor is yours.
Thank you very much, Kumara. Let me share my screen with you all and close my window so you don't hear the construction outside of my office. Can you see my screen?
Yes, we can see the screen and we can hear you very clear. Please go ahead.
Wonderful. So good morning, afternoon, and evening to everyone joining around the world. As Kumara said, my name is Nathan Rockford-Parnell. I handle science affairs at the Climate and Clean Air Coalition. I want to talk to you a little bit about the importance of addressing methane emissions globally, and particularly in the waste sector. And following on that introduction, my task here is to give you some good arguments for action to mitigate methane in the waste sector, which are grounded in the latest science. So let me begin quickly by talking about why we want to mitigate methane, independent from other climate forces or in parallel with other climate forces. So methane is a short-lived climate pollutant. It has a lifetime in the atmosphere, generally of about a decade. This is rounded down a little bit. In the latest IPCC report, it used to be 12 years was the average. Now it's 10 in AR6. Over a 100-year time period, methane has about a 29 times greater impact per molecule on global warming than CO2. Over a 20-year period, it's about an 84 times larger impact on the climate than CO2. So it is a substantial climate forcer on a molecule by molecule basis. And also, according to the latest IPCC analysis, it is responsible for approximately half a degree of the warming that we've experienced in the last 150 years. So since we've experienced about 1.2 degrees of warming. It is about 45% of the warming that we have experienced in the net. Methane also contributes, it is the largest single contributor to the formation of tropospheric ozone. Ozone is a major air pollutant and a greenhouse gas in its own right. It is not emitted directly. Instead, it forms in the lower atmosphere from the interaction of certain both natural and anthropogenic pollutants and interacting in the presence of sunlight, methane being one of the largest contributors to its formation. And ozone is estimated to kill approximately 100 people prematurely every single year from exposure to it. And this is deaths caused by respiratory disease, heart disease, damaging airways, causes asthma attacks in children, and serious respiratory distress, particularly in the elderly. Ozone is also a highly reactive air pollutant that damages ecosystems. So it suppresses ecosystem growth and plant growth. This is translated most directly for human beings. This translates into a up to 15% reduction in annual yields of major staple crops around the world. This is a global average. It's higher in some places and lower in others. In South and Southeast Asia, it's particularly acute as a problem. So methane adds up to being a particularly important pollutant to manage, not just because of its large climate impact, particularly in the first 20 years following its emission, but because it is a substantial contributor to premature death and damaging of ecosystems, damaging of food security, and really retarding and repressing a lot of activity towards a number of sustainable development goals. So one final point on this slide. So methane really comes from three main anthropogenic sectors. It has both natural and human sources, but three human sources make up the majority of human emissions, which are a little over 50% of total methane emissions every year. Agriculture is the largest single human source of methane, largely from manure management, rice paddies, and enteric fermentation. That's cattle and other similar animals burping up methane. Fossil fuel operations represent about 36% of total emissions. It's the number 2 source globally. That's coal, oil, and natural gas. Production, refinement, transmission, and use. And then the waste sector represents about 20% of global anthropogenic emissions. It's the smallest of the three main sectors, but it is still a 1/5 of total emissions and a really substantial contributor to global anthropogenic methane. And that includes both waste, so urban waste, industrial and commercial waste, and wastewater treatment as major sources of anthropogenic methane emissions. So going to putting this all into context, what does this mean in terms of the climate? Kumar, you made that comment earlier about the waste sector's methane emissions being a very small portion of total greenhouse gases. That's when you convert all greenhouse gases into their carbon dioxide equivalents and then treat them all as carbon dioxide. Yes, methane becomes a really small component of the total using that metric. However, I would urge particularly this community, because you have an interest in consider that methane is actually substantially different from CO2 that it's worth holding apart and looking at separately. First, before considering how it compares as a component of total greenhouse gas emissions. And this is something that the global climate scientific community has been doing for quite a long time. This is a figure that comes from the 2018 special report by the IPCC on the 1.5 degree target. And what this breaks down from the models that were run, about 41 models that were developed that actually met the objective of putting us on a pathway to achieve 1.5. These are the bands of mitigation that these models assumed was necessary to put us on that pathway. And it splits it up by a number of different major climate forcing components. So on the left, you have the graph of total net CO2 emissions. And on the right, you have three smaller, methane at the top, black carbon, which is a component of fine particulate matter air pollution in the middle, and then nitrous oxide emissions at the bottom. And what you'll see, I think, a couple of important things here. So particularly when it comes to this concept of net zero, if you look at these graphs, and I apologize, they are a little bit small, but you can find the zero line on the x-axis. For the graphs on the right, zero is at the bottom of the graph, and for this graph on the left, zero is a little bit on the lower middle portion. There's only one of these pollutants that goes to zero, and it's CO2. CO2 is the only greenhouse gas that needs to go to zero, and in fact surpass zero in about the 2050 range, to put us on a path to sustainably meeting our 1.5 objectives. Methane never goes to zero. Black carbon never goes to zero. Nitrous oxide never goes to zero. Methane, we don't know how to get methane to zero. And according to these models, it doesn't have to go to zero. It would be ideal if it did. It would make it a lot easier for us to achieve our climate objectives if we could get methane to zero. But reducing methane emissions is necessary. It has to come down by about 45% by 2030, and then sustainably go lower over the course of this century. But it has to do it simultaneously with CO2 going to zero. But it doesn't happen with CO2. And it is actually not part of the accounting of achieving net zero on CO2. And in fact, if you combine methane and CO2 and try to bring both of them down to zero as a CO2 equivalent commitment, it actually presents really substantial challenges. One, because methane emissions, we don't know how to get them to zero, since they are so substantially more powerful than CO2 as climate forcers. It just means that we would have to reduce CO2 through afforestation, reforestation, artificial capture. We would have to reduce CO2 that much more than what we already need to do. And reaching zero at CO2 in CO2 emissions by 2050 is already enough of a challenge. I'm not so sure we want to make that any more difficult. So just as this is, I think it's important context to recognize that methane is something that needs to be reduced. It needs to be reduced dramatically, but it needs to be reduced dramatically as an independent objective of reaching net zero CO2. Both of those things need to happen to put us on a pathway to 1.5 and 2 degrees for that matter. And I should say we shouldn't ignore all the other climate forces. All of them have to come down substantially as well within this decade and beyond, but none of them similarly go to zero. So what does this mean for us right now in terms of our commitments, and what kind of mitigation do we need to achieve? So unfortunately, despite the fact that we know we have to reduce these pollutants by a truly Herculean amount, methane emissions in particular are going up right now instead of down. They're going in the exact wrong direction. Right now, without any additional action, methane emissions are expected to continue to rise, at least until 2040, if not beyond. In this last decade, methane emissions have increased more rapidly, or I should say concentrations in the atmosphere have increased more rapidly in the last decade than at any time in the last 40 years. So they're actually increasing in rate and scale. And right now, current concentrations are well above the levels necessary to get us to 2 degrees according to the IPCC, let alone our true objective of getting on a sustainable pathway to 1.5. So, as I already said, the Paris Agreement 1.5 target and the models that support it indicate that we got to get down by about 45% on average of total methane emissions by 2030. And that represents about a 4 to 5% reduction in total anthropogenic methane emissions every year in this decade, which was really quite substantial. And this graph kind of shows the radical shift in the trajectory of methane concentrations that would be necessary to to achieve this objective. So earlier this year, the Climate and Clean Air Coalition and UN Environment Program published the Global Methane Assessment, where we assessed just what's out there in terms of total mitigation potential and compared that to what the 1.5 models say we need to do to achieve mitigation. So here we've broken down among the three main anthropogenic sectors the total percentage reduction in emissions that would be necessary to get down to a total 45% by 2030. So it's fossil fuels, it's a 60% reduction, waste about a 30 to 35% reduction, in agriculture, 20 to 25% reduction to get in within to get on a 1.5 pathway. We assessed that this is possible. In all three sectors, the technologies and policies that we already know exist, that are already at scale, that already have an economic case behind them, if deployed globally, could get us down to 45% total, and could get us at or beyond the mitigation necessary in each of the three sectors to support that. So in the waste sector, there are three broad, well, I mean, there are a lot of activities, but broadly there's solid waste management, and that's both in residential and industrial. That's either methane capture or flaring of landfill gas. That's diversion of biological waste, recycling and reuse, landfills, or for industrial waste management, that's recycling and treatment and energy recovery. Then wastewater treatment, which is a more expensive set of measures, at least according to the models. It's about upgrading to secondary or tertiary methane capture at wastewater treatment facilities, and similarly in industrial facilities. And then on the consumption side, it's about reducing consumer waste and really pushing consumers to reduce their waste and also separate, to make it easier to separate biological materials from non-biological materials so that they can be moved to composting or methane capture. This is a fun little infographic that we created for the waste sector. It kind of indicates not just where methane is coming from, but also black carbon emissions from the waste sector. So what do we get when we mitigate? A few more arguments for why we should focus on methane in the waste sector and all anthropogenic sectors and the benefits from it. So as I said at the opening, right, methane is more powerful than CO2 in a shorter time frame. It lasts in the atmosphere for a much shorter time. So when you mitigate when you mitigate methane now, within a decade, the atmospheric concentrations have come down dramatically. That translates into benefits that you can feel in a meaningful way in the first decade after mitigation happens. And since methane not only contributes to global warming, but also contributes to the formation of ozone, reducing methane now also produces substantial public health benefits, agricultural and ecosystem benefits in the near term by reducing tropospheric ozone formation. So you get a whole suite of benefits very quickly when you mitigate methane. Many of these benefits are actually incredibly salient for particularly policymakers, much more salient for many policymakers than, say, reducing tons of carbon dioxide equivalent. And I'll just, for example, so a 30% reduction of waste sector emissions, which is what the green bar here, the lighter green, well, the green bar here shows a 30% reduction in the waste sector will get you 0.5 of a degree of avoided warming, which seems small, but it's really quite large in the grand scheme of things. It would avoid about 4,500 premature deaths every year due to the reduced ozone. It would reduce about 135,000 asthma-related ER visits. That's among children primarily. 5 million tons of avoided crop losses per year. And also, because this is a new factor that we've begun working with in the CCAC, because of the avoided warming and the avoided extreme weather events due to the avoided warming from methane mitigation, we expect that This will translate into substantial benefits in terms of avoiding lost work hours for people who work outdoors and would be unable to work during extreme temperature events. All of these things can be monetized. All of these benefits can be monetized, so we can express this in terms of the total economic benefit for communities. But in total, even without monetizing and expressing the benefit of avoided premature deaths as an economic cost, we know that about 60% of the measures in the waste sector are actually low cost or come at no net cost because they provide an economic benefit that would offset the cost of implementing the measure. So they're cheap, they're effective, or they're cheap-ish, they're cheaper than a lot of CO2 measures. They're effective because we know they exist. They can be implemented quickly. They achieve massive multiple benefits, not just for climate, but for a lot of other sustainable development objectives. So last two slides here very quickly. We have this really fun tool that we developed as part of the Global Methane Assessment. I encourage everybody to go and check it out. There's a web link here at the bottom of this slide. It allows you to scroll through different mitigation scenarios. You can look at methane emissions from various sectors. And then you can look at the benefit that would come for your country or any other country on Earth for mitigating methane emissions from that sector or all sectors. And it will translate, as you see the yellow bars down at the bottom, it'll show the economic benefit of methane mitigation. And this, we've got landfill management, wastewater management. All of the various mitigation measures are plugged into this tool. It's just a fun tool that you can use. Hopefully policymakers can use it, but also, communicators can use this to really, understand the raft of benefits. So final slide here. Just quickly, the CCAC, we have an engagement strategy for the next decade in the waste sector. And a new waste hub that is forming right now and will be underway this next year, where we'll be focusing on these 6 bullet points, different activities. I'm not going to go into it for time, but we encourage all partners to come and collaborate with us to raise awareness and really meaningfully reduce methane emissions from the waste sector in this coming decade. One final point on this, however, there is currently no focus within the CCAC on wastewater management. It is a major source of methane emissions from the waste sector, but it's one that our partners so far have not really focused on. And so anybody who's interested, particularly countries or organizations that are interested in dealing with wastewater, we encourage you to come and help us expand this engagement strategy so that we address wastewater and not just the solid waste emission sources. Thank you.
Yes, thank you very much, Mr. Nathan, for very interesting presentation and giving a clear frame for our discussion today, how important of the methane in achieving 1.5, 2-point targets by 2030, 2050, zero waste targets in Asia and the Pacific. But at the same time, you highlighted the waste sector contribution to reduce methane is 30 to 35%. This is what we need to highlight, because today our discussion is how waste sector can be contribute to the zero waste societies in the Asia Pacific region. So also, your last slide, the show us it is very important, not only focusing the landfill side on reducing methane, but also looking at the whole integrated waste management system. So I think this gives our next presenter to make how these policies on the really make action at the national and the local level. Before I am going to invite our next speaker, I would like to ask the audience, so if you have any question, please put them into the question and answer boxes. So we will take all of them after the 3 presentations. So then let me invite our second presentation, Ms. Maria Delia Cristina M. Valdez. She is a Chief Solid Waste Management Division, Environmental Management Bureau, Department of Environment and Natural Resources, Philippines. So Ms. Dalia, please make your presentation.
Yeah, thank you very much, Kumara-san. May I ask the Secretariat to share my slides? Thank you very much. Well, good morning, good afternoon, and good evening to everyone, wherever you are in the world today. I am hoping earnestly that you are all safe and well. Before anything else, I would like to express our gratitude to the IGES, specifically to the Center Collaboration with UNEP on Environmental Technologies for the invitation and opportunity given to us to present how the government of the Philippines has fared and where it is in its implementation of the strategies on short-lived climate pollutants and on municipal solid waste. Next slide, please. Thank you. Even before the talks of the nationally determined contributions, the solid waste management has been a significant part of the climate reports, starting from the national communications submitted in the year 2000 and in 2014 to the UNFCCC. Although not a big emitting sector, still the significance is highly considered like the other sectors we have for our climate reports. Personally speaking, I started my involvement in climate change linkages to solid waste in the start of the development of the NDC of the country, and then we continued to the development of the submitted NDC for the country. With the current Philippine NDC, we revisited the parameters we have identified in the INDC, submitted and assessed the applicability of to the NDC. Recalculation was also done based on the updated data sets, parameters, and assumptions for the adoption and adaptation and mitigation measures. Next slide, please. The contribution of the solid waste in the current NDC of the Philippines was derived using several analytical tools like the 2006 IPCC inventory software, the sectoral modeling tools, cost-benefit analysis, and multi-criteria analysis, among others. The mitigation options then included composting, methane flaring in sanitary landfills, digestion of organic solid waste or the anaerobic digestion, methane recovery from sanitary landfills for electricity, and the use of eco-efficient soil cover. The generated results of the analytical tool were then used in the 2018 to 2019 as one of the bases of the development of the national strategy to reduce short-lived climate pollutants from municipal solid waste sector in the Philippines. Next slide, please. Just like the preparations we did for the NDC contributions of the solid waste sector, the national strategy also underwent multiple stakeholder consultation. It was spearheaded by the DNR-EMP Solid Waste Management Division and then Climate Change Division, now the Climate Change Information and Technical Support Division of the DENR, with guidance from the National Solid Waste Management Commission and coordination with Climate Change Commission, of course, with assistance of IGES. In addition to the results of the study, in addition to the results of the analytical tools previously mentioned, the SLCP inventory utilized emissions quantification tool where it looked into a life cycle assessment of the solid waste. To be integrated as part of the NDC, and for consistency, the SLCP inventory also used the 2010 as its base year. In total, the net baseline emissions from greenhouse gas and black carbon are equivalent to 5.43 million tons of CO2 equivalent. And if SLCPs only, that would equal to 6.50 million tons of carbon dioxide equivalent, with 15% is due to black carbon. The strategies were formed through a series of discussions and consultations, and a core of group experts were formed to assess the strategies identified. Next slide, please. There are actually 7 strategies identified for the reduction of SLCPs from the Philippine municipal solid waste sector. Strategy 1 and 2 would primarily provide solutions to reduce methane emissions by avoiding further methane generation and by treating methane that is already being generated at the solid waste disposal sites, or meaning those are in open dump sites. Baselines and targets are based on the enhanced cost-benefit study as of January 2018. For example, the target set for Strategy 1 adopted a long-term projection of having at least 50% of bio-waste composted or digested by 2050. A similar approach was taken into consideration in setting the targets for Strategy 2, but with quantitative validation using the emission quantification tool. The reduction of air or avoidance in black carbon emissions is addressed through strategies 3 to 7. The envisioned recycling targets has been identified based on baselines in recycling industry development study. Strategy 4 adopted a key element under subsector outcome 2 of the Philippine Development Plan for 2017 to 2022. Targets set for the reduction in burning of solid waste at solid waste disposal sites in Strategy 5 were correlated with the closure and rehabilitation of unmanaged solid waste disposal sites. In addition, Strategy 6 emphasizes the importance of improved waste collection coverage and frequency to discourage backyard burning, while Strategy 7, which deals with reducing vehicular emissions, may be classified as a transport sector strategy. The MSW sector will actively affect whether to use low polluting waste collection vehicles, as well as if municipal solid waste collection routes and transport schemes could be optimized. Next slide, please. The total climate impact mitigation potential from MSW management through the proposed 7 strategies is in projected years of 2025, 2030, and 2040 are 32%, 48%, and 56% respectively, relative to the 2010 base year practices. The strategy also identified a number of cross-cutting considerations which are crucial enabling mechanisms from the SLCP reduction strategies to be successfully and sustainably implemented. The National Solid Waste Management Commission is currently updating these cross-cutting considerations in the National Solid Waste Management Strategy. Next slide, please. The national strategies are within the realms of the salient provisions of our local law on ecological solid waste management, which is the RA 9003 or the Republic of 903. However, for some newly introduced strategies like the waste to energy and the use of eco-efficient soil cover, both are not widely used yet locally. There is still a need for a national study to support its full implementation. Next slide, please. As for the challenges, many LGUs and private entities have done well in implementing ecological solid waste management programs such as segregation at source, promotion of reduction, reuse, and recycling, or the 3 Rs, and development of recycled products and markets. However, with the new technologies and changes beyond the walls of the law on solid waste management, the LGUs who are the main implementers of the law on waste management, the challenges still persist. Implementing the strategies to reduce SLCP will mean added limitations to the current struggling technical, organizational, and financial capabilities of the local government units. Similarly, the lack of somehow political will to prioritize solid waste management and the bureaucratic procedures in procurement are still thriving in the government system. Next slide, please. For our ways forward, we are looking at improvements in the data management, both for the inventories and for the target mitigation measures and strategies. Full implementation of the national strategies to achieve the targets, and the pandemic has put on hold to some of the activities we are supporting. We're looking at continuing our activities in full speed once our national become favorable for the activities. Next slide, please. With that, thank you very much for listening.
Thank you very much, Ms. Dalia, for the sharing the experience of the Philippines in developing its first national strategy. I think this is one of the first in Asia to reduce SLCP at national level from the waste sector. As one of the partners who involved that process with the support of CCSC, so IJCCT is very happy to see how you looking at the strategy and how you integrate it into your NDCs and the follow-up climate action. So it's really glad for us to look at the progress, what you are doing in Philippines. At the same time, you show us as Nathal also mentioned, so it's possible. So the technology availability and the policy is available in the Philippines, so you can reduce more than 50%, more than 40-50% of methane and other short-lived climate pollutants in next 10 years time frame. So this is possible, but we need to take actions to make it a reality. So thank you very much for sharing this experience from the Philippines. So I think we have many questions. So I also have a couple of questions we can discuss further after all the presentations. So thank you again. So then let me invite the next speaker, Ms. Misato Dilip. She is an associate expert, United Nations Environmental Program, International Environmental Technology Center. So she will share with us the experience of ITC working on the Western climate change. So Misato-san, please go ahead.
Thank you very much. Do you see my screen okay?
Yes, we can see you.
Okay, thank you so much. My name is Misato Ziri. I'm working for UNEP ITC, and I'll talk about knowledge and technology transfer for reducing emissions from the waste sector. Just very quickly before going to this topic, I just want to introduce who we are. We are the International Environment Technology Center, part of the UNEP, and we focus on holistic waste management. And ITC publish many publications, namely Global Waste Management Outlook, and this Global Waste Management Outlook 2 is coming very soon. And we publish various regional outlook as well. And we work various countries, and we closely collaborate with IJCCT. So as speakers have already talked about this, but open dumping and burning is very common practice in many low to middle income countries, releasing SOCPs, methane and black carbon and other hazardous pollutants into the atmosphere. And the key finding of the Mountain Waste Management Outlook, which ITC produced, is stating that almost all solid waste in mountain regions is disposed through burning and dumping. Countries like Bhutan, Mongolia, and Nepal have great potential regarding the reduction of short-lived climate pollutants generated by the waste sector. So in this context, ITC has been implementing this waste and climate change project funded by Japan government. We partner with WWF Bhutan, the Asian Foundation in Mongolia, and Lead Nepal in Nepal. And the project supports the partner countries at national and local level by developing policy framework and identification of the technology for the implementation of national mitigation targets, i.e. NDC, from the waste sector. And project also helped accessing green financing for larger scale investments in appropriate environment sound technologies to demonstrate GHG mitigations opportunity in the waste sector. And lastly, the project also made various communication materials to raise awareness and promote potential of waste sectors to reduce emissions, and also highlight the importance of reduction of waste and proper separation at source for recycling. Mongolia and Bhutan have developed their respective national waste management improvement strategies and action plans with robust baseline assessments for evidence-based policy development, which all have explicit links to climate change, like reducing FLCP. So just to give an idea, in 2018, under this project, the partner conducted an emission estimation analysis using the solid waste emission estimation tool called SWEET in Ulaanbaatar city. The figure shows that the GHG emissions in Ulaanbaatar city have increased continuously and will see an exponential growth if things remain unchanged. And in line with mega trends, including population growth, especially in urban areas like Ulaanbaatar. This graph shows that landfills and landfill gas combustions and waste burning are the two major sources of emissions in Ulaanbaatar cities in waste management. And they are expected to grow exponentially under a business as usual scenario. Hence, Mongolia government has committed to reduce GHG emission by 14% by 2030 compared with a BAU scenario, with 0.6% of this reduction being achieved in the waste sector through improved recycling of solid waste and increased treatment of wastewater. So for waste management, the main priority was to divert waste from landfill and ended up open burning. So in order to achieve this target, the project helped develop policy and select technology to reduce greenhouse gas emissions from the waste sectors. Mongolia conducted its last waste composition study in 2006. And thus the results and the data were outdated for policy planning. Therefore, a new waste composition study was conducted in Ulaanbaatar city to update the existing solid waste database and inform policy development. This study is the first conducted in winter and summer for both apartment and gay area households in the city. The results show the seasonal variations in the sources and composition of waste in both apartment and traditional house gay areas. In gay areas, ash is the major source of waste, with more ashes in winter than in summer due to more combustion in winter. In apartment areas, and like many other countries and cities, food waste is the major source of waste, with smaller seasonal variability than in gay areas. So the result provide useful information about complexity about the waste composition in Ulaanbaatar city, but on average, about 20.7% of the total waste is organic waste. So the projects facilitate the process of identifying what is appropriate environment sound technology is for waste management improvement. And this technological focus was largely informed by the results of the waste composition study, which show that the organic waste is the largest portion of waste generated by these three countries that we implemented, especially in city. And the country went through using methodology called sustainability assessment of technologies. And as a first step, the project conducted technology assessment. The first assessment determined the current status of waste technology used in Mongolia, for example, along the entire waste value chain. And based on that findings, the project identified international best practices that could be applicable in the context of Mongolia to bridge the gap in the value chain and improve specific aspects of current waste management in Mongolia. So in Mongolia, for example, the group of experts also set the strategic and technical criteria for decision-making on the type of preferred technology and undertook technical screening and shortlist technically and financially viable technology options. So let's see what technology each country has identified to reduce GHGs for pilot. So in Nepal, as part of the technology assessment, the partner organization looked at neighboring country, India. Nepal decided the best way to divert organic waste is to set up solid and liquid resource management system. The project team has organized a study tour in India to learn about solid and liquid resource management system already implemented in India. So this system is firstly source segregation into organic and inorganic waste at each household, and this tricycle rickshaw to collect the waste from each household to the the solid and liquid resource management centers, where secondary segregation will take place. And at this center, wet resource will be fed to cows and used to feed to the biogas plant for lighting and cooking purposes. The dry waste then further be segregated for recyclable items, and these recyclable items will then be sold to the recycling companies and wholesale dealers. And similarly, Bhutan is also looking at how India has done for organic waste, and Bhutan has decided to pilot biogas plants. And the Bhutan team have also looked at technology from India's, especially Himalayan regions, where climate and topography is similar to Thimphu, the capital of Bhutan. Unlike these two countries, in case of Mongolia, to reduce SOCP, including methane from organic food waste, and demonstrate how organizations can set up their own sustainable food waste groups using locally available technologies, they have considered many options. They also looked at international examples where the climate is similar, like Scandinavia, but then decided to use local engineers' knowledge and expertise. They have decided tumbler composter and automatic composting machine. This is the first time when such prototype of composting technology are designed and installed in country. And this small and medium scale decentralized solution for food waste recycling composting technology has now been piloted in Ulaanbaatar city. This is a still pilot project, so they have faced some operational challenge due to the weather, as Mongolia's winter goes up to -35 or more. And they have put some insulation to the machine, and some machine can only be operational in the summertime, and some machines placed inside and can be operational year round. But we'll see how this composting machine can turn out in this country. So knowledge and technology transfer offer a great potential in mitigation of emission from the waste sector if the climate and topography conditions are similar. But however, I just wanted to emphasize that other enabling factors also needs to be put in place for application of any mitigation technologies. First one is the country needs to have enabling policy and legislation framework. And this also includes procurement policies. Many partners, government have based these procurement policies especially if they're transferring a technology from other countries. And secondly, the ability to conduct effective segregation of waste at source is very important, as one of the most significant challenges of generating value from waste is cross-contaminations of wet waste with dry. And inorganic material contamination can reduce the effectiveness of an organic processes and the quality of any product. And this can be done through awareness raising and offering educational and training programs. And thirdly, proper infrastructure in place, such as bins and collections and transport system. And this is very important enabling factor. And fourthly, strong political will to allow infrastructure development and policy development to happen. And lastly, but not least, technical capacity through training and various educational programs. So that's it from me. Thank you so much.
Thank you, Ms. Sato-san, for your kind presentation and sharing with us about ITC work in the developing countries. So CCT is very happy to be part of this ITC work in developing countries. So I think we have something 10 minutes to have a short question and answer and the discussion sessions. May I kindly ask all our speakers to switch on their videos? I have one question from the audience, so I think this is going to be Mr. Nathan. It's one thing is like methodological issues. So it says like currently methane global warming potential is 100 to approximately 25. So whether we can change it to 36 or any possibility. So may I ask Mr. Nathan to make any answer for this, if you can?
So, I mean, it's a good question. So global warming potential is a metric used to compare climate forcing of different pollutants. So essentially, the energy that they allow to be trapped from the sun in the climate system. That's what we're measuring, the additional energy added to the system by a particular pollutant. So over 100 years, it adds, compared to CO2, it adds about 28 to 29 times more energy to the system. That changes in it, and the GWP metric has changed over the since it was introduced more than 30 years ago. It has changed. It's not something that we ourselves can really impact. It's a metric. It's a conversion metric. It's just like, you know, converting metrics to imperial units, right? Feet to meters, right? Except in this case, it's actually because it's comparing against CO2 and it's comparing energy added to the system, it really does matter how much of these particular pollutants are in the atmosphere and how quickly they're coming down. So, I mean, but I guess all of that's irrelevant. To answer your question very specifically, we ourselves cannot impact the relationship that is being expressed in GWP. It is, however, changing as the science gets better and our understanding of the impacts and the radiant forcing actually changes. And it changes based upon the ratio of these pollutants and how quickly they're changing in the ecosystem. So in AR6 or AR5, the fifth assessment report of the IPCC 7 years ago, it estimated that the GWP at 100 years for methane was about 24. Now we're up to about 29. Right? There are a lot of reasons for this, but it gets adjusted. It's not us impacting that. It's an assessment of the energy that's added to the system and an improvement in the science.
Thanks, Nathan. So I think it's clear for the question. And let me ask the next one from my side to Dalia. So, and I saw your presentation, so you highlight the importance of this using EQT tool and other IPCC tools in using modeling your SLCP emissions in the Philippines. So this also something methodological issues, how the data availability in the countries and how I saw your last slide show us the importance of the data and the MRV to monitor, because waste management is finally the local governments is doing the implementation. So national plans should be linked with local government action. So how your institute or you thinking to link data management and MRV system to make monitoring the data?
Thank you for your question, Kumara-san. Actually, it is one of the challenges that we are facing right now, and we are trying to establish our robust data. We are aware that not all of our local government units are reporting robust data to the national government. And we wanted to have a system in our office that we could use, or data that we could use to link it with the MRV system. And right now, the Climate Change Commission and also the DNR through the Climate Change Service is stepping up on making some efforts to include in their policies and in their work program a capacity building to develop an MRV system for the solid waste sector. Right now, we don't have it right now, the MRV system for the solid waste sector. And it is now that we are planning to have a system for the solid waste sector, solid waste subsector.
Thank you very much. I think
you.
that's very, very important, and for us also that is good to see how we can work together in this subject with the Philippines. So thank you very much. So let me ask my next question to the Misato-san, because you shared with us how the IKI project is help ITC to transfer technology, local technology to the developing countries. This shows us it's very important, because we know we have technology, we can manage to reduce greenhouse gas and methane from the waste sector, but the financing is the issue for a lot of developing countries, cities, and the government. So how you think creating this climate funding support for waste sector and also creating innovative funding systems to support waste management activities, how you feel it's easy or it's challenging, and what's your ideas?
Thank you very much, Kumara-san. As you point out, it is very challenging, as you mentioned in the openings. The waste sector it looks in actual numbers, it looks quite minor sectors. It deemed as a minor sectors. Hence, there is not much funding opportunities to these major climate funding mechanisms. So it's very important for us as a unit for any waste management sectors to highlight the potential, not just the waste sector as a just as it is, but also waste management as a whole, includes from collections to recycling, and this also leads to plastic issues and everything. If you count the indirect emission mitigation as well, it would cost. It would have a high potentials of mitigation of GHG emissions. So as international organization, I think it's important to highlight these issues and shed light to waste management sectors that usually been neglected in terms of climate mitigation. So I think very important for us to highlight the potential, not just the numbers of the waste sector, but other sectors, including the waste management as a whole. Thank you.
Thank you very much. So this is what I think we need to work hard to bring this the waste sector in the climate financial mechanism. So thank you very much for this your opinion on this matter. So I think we're almost in the final stage of the session. So time is going to finish. So let me summarize a couple of key points that we try to discuss and learn from the discussion. So we found it's very clear that we need to address waste and resource management firmly in the local, national, and the international agendas to go beyond. We already finished COP26. We had to go beyond COP26. We need to address waste sector in these plans and the national agendas. So for that, I think what we discussed, waste management need to be more integrated, both Ms. Delia and Ms. Sato-san presented. So including integrated resource management within the waste management, not only end of pipe methodologies. And also it's need to be considered more methodological, political, policy and financial issues. I think these are very general, but it's very important for us to make waste sector in this climate agenda. So thank you once again for all our three speakers, their valuable presentation and the comments. So this is the end of our session. I also want to thank all the participants who join in with us in this session. I hope our discussions both fruitful and insightful. ISAP 2021 is ongoing through the 3rd of December. I hope to see you in other sessions or at the next ISAP in the next year. So again, I would like to thank our speakers for your time and valuable presentations, comments, and also our audience. So this is the end of our session. So thank you very much. Have a good day and good night.